Hi, in this video I want to discuss this circuit. We developed this circuit for an ultra-low power circuit for smart home automation. So the circuit should run many years on one set of batteries. The prerequisites were that we use two cells of a AA or AAA battery. So the usable voltage would be 1.8 to 3 volts. The circuit should turn on automatically when the batteries are inserted, and it should be turned off by the microcontroller, which measures the voltage, and when the batteries are empty, the whole circuit disconnects itself from the battery. So the batteries, if they are rechargeable, don't get destroyed and deep discharged. So what's the clue of this circuit? First we have here our voltage source, the two batteries in series. This is the switch, which is not really a switch, it's just when you insert the cells, it's like a switch, mechanical. We have no other mechanical switches. This is also a requirement for this project, so we don't have to do with contact corrosion. So what we see here is a sort of an SRAM cell. So we have here two CMOS inverters which are connected in series. So just leave away these three components, and this is the output transistor. We have here some resistance for current limitation on the transition when this gate node goes from high to low, or vice versa. We have a shoot-through current, some sort of, and that are the current spikes in typical CMOS applications and circuits. We reduce this current dramatically by having large resistance here. So on power on, these two capacitors define the voltage or the level of this SRAM cell. So these capacitors are assumed to be discharged. When the power comes on this rail, the capacitors in the first moment have zero voltage, and so we have here a low input. It gets inverted by this CMOS stage. Also we have here a high voltage defined by the capacitor and the supply voltage. So this is the same logic level. This drives a high, and also the input has a high, so nothing collides. This drives the next CMOS inverter, and we get here the feedback loop. So high, no, a low, a high, again a low, and this drives the low again. The nice thing about this is that it doesn't draw any current in a static state. So the only currents we could measure would be leakage currents of transistors and the capacitors. So we get a low on the output of this SRAM cell, and this turns on our P-channel MOSFET, which feeds the rest of the circuit, the microcontroller and so on. If the microcontroller decides to shut off itself, it drives this transistor with a short high signal. So this capacitor will charge, and we get on this node a low. This gets to a high here. We charge this capacitor too. We have a high here, and we have a static low here. Even if we turn off the transistor, which will happen when the microcontroller on this side has no voltage anymore and no supply anymore. Yeah, and also in this state we draw zero current. What we really have to take care about is that we don't feed some current into the microcontroller through its protection diodes, which all I/O ports have. Yeah, this doesn't happen with this circuit. Again, zero current, so the batteries can stay in the disconnected state or in the turned off state again for some years perhaps. Yeah, I'm very happy with this circuit. What you have to take care of is that the threshold voltage of these transistors is rather low, so you cannot use any MOSFET you can find on the market. So that's the difficult part of this circuit. But you find transistors with a threshold voltage of 0.5 to 1.3 volts. Maximum or minimum. So they should do the job. Yeah, thanks for watching. I hope you find this circuit useful. Yeah, see you next time. Ciao.